Alright, this video is about composite figures, and we are going to be using the area addition postulate to find the area of composites, and then using composites to estimate the area of irregular shapes. So, first of all, a composite is any figure that's made up of simple shapes, like triangles or rectangles, trapezoids, or circles. And to find the area of a composite figure, what you're going to need to do is find the area of the simple shapes and then use the area addition postulate, which says that the area of the whole region is the sum of the areas of its non-overlapping parts. So you just pretty much need to add all the shapes together. So we can find the area of a composite of the shaded area. We can find the area of the shaded piece here by taking the shape and dividing the figure into parts. So when we divide it into sections, I can see that I've got like a half circle up here, and a triangle on the side, and then also a rectangle. So we'll find the area for each part individually and then add them together. So first, the area of the half circle. Well, we know that the formula for the area of a full circle is pi r squared. So since we only have half of a circle up here, our area formula is going to be 1/2 pi r squared. And then we'd have to plug in to the formula, what would our radius of this circle be? Well, the diameter all the way across here is 20, so half of that would be our radius of 10. And so plug in 10 for r into the formula, and we get that the area of the half circle is 50 pi. Alright, now let's find the area of the triangle. Well, the formula for the area of a triangle is 1/2 base times height. And we can see that the height on this side, the red line, is going to be the same as the height on this side where the 14 is. So 14 is our height. To find out how much the base is, we only want the base on this part of the triangle, so we're going to have to do this whole line 32 and subtract off the side of the rectangle, the 20, so do 32 minus the 20, so we can just find out how much is on the triangle right here, and so that gives us 12 for our base. So plug in 1/2 12 times 15 into the formula, and we get 84. And the area of the rectangle is just base times height, so we have 14 times 32. Or sorry, 14, not 32 though, yeah, 32 is the whole side. 14 times 20. Alright, so now to find the area of the entire shaded region, we just have to add together the things we got for the half circle, for the triangle, and for the rectangle. So we add, the circle was 50 pi, and then we got 280 for the rectangle and 84 for the triangle. Good. Okay, let's see if we can find the area of this particular composite. So when we look at this, there's different shapes we can break it down into. When you get ready to divide this figure, I think I'm going to go ahead and divide it so that I have a parallelogram on top here. Looking at this parallelogram here, green, and then the triangle on the bottom. So now the area of a parallelogram is base times height. So when I try to find the area of this parallelogram, I need to find the base and the height. So the height is the distance that's between the two bases and has to be perpendicular to the side. So looks like this height of 5 is marked perpendicular. I can see that with the little red 90 right there, with this side of 8. So since those two sides are perpendicular, we can use them as the height and the base. So we're going to use 8 and 5 for the height and the base. The area of the parallelogram is going to be 8 times 5, 40. And then the area of the triangle. The triangle, I can see the base of the triangle is 10, and the height, again, the base and the height are marked perpendicular, as they must be. And so 1/2, 5 times 10. Alright, gives us the area of 25 for the triangle. So now we just add them together, and 65 is the total area for the entire shape. Okay. Now, we can also find the area of composites by subtracting. Alright, in this picture, I don't know if you can tell this, but the light blue has been shaded inside here. So it looks like we have a circle, but it's missing. This trapezoid here has been subtracted out from the area of the circle. So we're going to have to find the area of a circle and then subtract out the area of a trapezoid. So the area of a circle is pi r squared, And pi r squared, when we look at this, we can see that the diameter of the circle all the way across is 20. So the radius must be half of that, 10. So put 10 into the formula and we get 100 pi for the area of the circle. And then for the area of the trapezoid, did you remember the formula for the area of a trapezoid? 1/2 base 1 times base 1 plus base 2 times the height. Alright, so we're going to go ahead and use that. We've got my bases of being 20 and 12 are the two parallel sides of the trapezoid, and then the height between them is 8. So go ahead and plug those into the area of the trapezoid formula. We get 128 for our area of that. And then we just need to subtract the area of the trapezoid from the area of the circle to get our final answer, 186.2. Let's do one more with subtraction. When we look at this one, this time a square has been subtracted from the circle. So I need to find the area of this square and the area of the circle and then subtract them. So let's do the circle first. The area of the circle, again pi r squared, well if the diameter of the circle is 6, the radius must be 3. So we have pi 3 squared, 28.3. Now to find the area of the square, it'd be helpful if you break the square down into thinking of it as triangles, because they don't give us the sides of the square, so we would have to use some trigonometry to find the sides of the square. But we can also do this by just looking at one of these triangles. And if we say that the area of the total square is going to be 4 of those triangles, because we know that if this whole side is 6, this side must be 3. So the length and the base and the height of this triangle are both 3. So we're going to say 4 times 1/2 base times height, 4 times 1/2, 3 times 3. So plug into the formula for area of a triangle was 1/2 base times height, and there's 4 of them. And we get 18 for the entire square. So now I just subtract the area of the circle minus the area of the square, and 10.3 is our answer. So in this, okay, and one more type of thing I want you to be able to do, and that is to find the area of irregular shapes. So you can do this by breaking the shape down into simple shapes. Like over here it looks like I have a triangle, okay, and maybe I can make this piece here another triangle and another triangle down here, okay, and then what would this be? Okay, we could have like one square here and a triangle here if we wanted to do that. So you can just break it down however you'd like, and then find the area of each individual shape that you've made and add them together. So you're going to divide the composite figure into simple shapes. So let's see if we can do that with this shape. Let's see if we can draw a composite figure that okay, first we have to draw the, okay. So now what we're going to do is take this shape and break it down into simple shapes. So I've chosen to break it down like this, so that on the side here I've got a triangle, and then I've got this rectangle, and this is kind of like a half of a circle. So I know it's not exact, but we're just estimating, and we'll use these to estimate the total area. So the area of the triangle, 1/2 base times height. So looks like the base is going to be 2. Okay, we have to do a base and a height that are perpendicular, and then also a height of 2. So 1/2 base times height gives us an area of 2 for the triangle. And then for the half circle, we've got a half circle. Looks like the radius of the circle is going to be what, 1.5, because it's about 3 wide. So 1.5 for our radius. Plug that into the area of a circle. We only want half of the circle, so 3.53. And then the area of the rectangle is 2 times 3. And when we add them all together, the shaded area is about 12. So in this lesson, the main thing that you need to know is you need to remember all your area formulas. So you know the area of a circle is pi r squared, and triangle 1/2 base times height, and rectangle and parallelogram are the same. Okay, and then the area of a trapezoid 1/2 height times base 1 plus base 2. All right, so great.